Over the past years, large deep learning language models with billions of parameters have improved the state-of-the-art in nearly every natural language processing task, from machine translation to document summarization. Self-supervised learning has expanded beyond language to include images and videos. Joint semantic representations now operate across modalities as multimodal pre-trained models for generation and understanding, which enabled scenarios like image captioning. Overall, connecting language with other domains in these large pre-trained models creates incredible opportunities for innovation. My name is Nan Duan, and I'm a principal researcher and research manager at Microsoft Research Asia. Today, I'm going to share with you how we are capturing the semantic connection between natural language and programming languages. I personally believe that artificial intelligence has the power to fundamentally transform how we understand software development. The code intelligence field seeks to help software developers by leveraging AI to develop large-scale pre-trained models for code and natural languages. And this is exactly what we have been researching at Microsoft Research over the last few years. We recently created a system called CodeBERT for multiple programming languages to support scenarios like transformation between code-code, code-text, text-code, and text-text. So let me tell you what this can mean for developers. When developers are confused about what to write next, code completion systems can help by automatically completing the following tokens given the context of the edits being made. When developers want to implement Java code with the same function of some existing body of Python code, code-to-code translation systems can help translate from one programming language like Python to another like Java. When developers are looking at an unfamiliar piece of code, they can rely on code summarization to provide them with a natural language description of what the code actually does. When developers want to find code that was written by others with the same intent, code search systems can help automatically retrieve semantically relevant code given natural language queries. And finally, we can automatically translate a document into dozens of languages. We trained CodeBERT on both bimodal and unimodal data. Bimodal data means parallel data of natural language code pairs, and unimodal data means codes without paired natural language text. What we do in essence is to take a code text pair as the input and randomly mask tokens from both sides. The pre-training task is to recover the masked tokens. We then fine-tuned CodeBERT parameters for natural language code search and code documentation generation, achieving state-of-the-art on both tasks. You can reproduce the experiments in our latest paper, which is available through our GitHub repo. Some of our research breakthroughs are already being implemented in the tools you use every day, like Visual Studio. But the field of code intelligence is still in its early days, and there is still so much more that we can achieve. My dream is to be able to empower any creator to easily develop softwares in any language, be it natural or programming, with the help of an AI code programmer. But together, there are many big challenges we will have to overcome. Among was that the field of code intelligence lacked a benchmark suite that covered a wide range of tasks. We saw how having a diversified benchmark dataset was significant for the growth of applied AI research, like ImageNet for computer vision and GLUE for NLP. But nothing existed for code intelligence. So researchers from my team in China, in collaboration with the developer division and Bing engineers, created CodeXGLUE, a benchmark dataset and open challenge for coding intelligence, so that we can push the field's boundaries in partnership with the community. CodeXGLUE is a collection of coding intelligence tasks and a platform for model evaluation and comparison. It includes 14 datasets for 10 diversified coding intelligence tasks covering the scenarios we discussed before. To make it easy for participants, we developed 3 baseline models to support these tasks, including a BERT-style pre-trained model, which is good at understanding problems, We also include a GPT-style pre-trained model to support the completion and generation of problems. And finally, we include an encoder-decoder framework that supports sequence-to-sequence generation of problems. We invite the community to participate in this open challenge to help us accelerate the progress being made in the field of coding intelligence. Moving forward, we will extend CodeXGLUE to more programming languages and downstream tasks. And we will do this all while continuing to push forward pre-trained models by exploring new model structures, introducing new pre-training tasks, using different types of data, and much more. So stay tuned for the incredible progress in this exciting field. Thank you for listening.